This is part 3 of the videos on section 5.3, partial derivatives. Here we're going to look at the second order partial derivatives. And these are simply partial derivatives of partial derivatives. In Calculus 1 you learned about higher order derivatives. You took a second derivative, which is a derivative of a derivative. Here we're going to take a partial derivative of a partial derivative. And so we have the partial derivative with respect to x. We think of it as a function in its own right, and we take the partial derivative of that with respect to x. Our notation is f sub xx. With our partial notation, we have the partial derivative with respect to x of the partial derivative of z with respect to x. And then, because it's a second order partial derivative, we have this notation, which is very similar to Leibniz notation for a second derivative. Then we can take this same partial with respect to x, but take the partial with respect to y. We have similar notation. Here we have partial with respect to x on the right, partial with respect to y on the left. The one on the right is the one we have done first. Because if you look at the notation here, this is the one we did first, and we did the partial with respect to y of this partial derivative. Forgot the limits over here. So the limit as h goes to 0. We have f sub x, x plus h, comma y, f sub x minus f sub x of xy divided by h, provided the limit exists. We do the same thing here. We start with the partial derivative with respect to y, take the partial derivative with respect to x. We have analogous notation, and then we have the limits. Limit as h goes to 0, f sub y, x plus h comma y, minus f sub y, xy. This is the partial derivative of y with respect to x. So we're taking x as our variable, y as our constant. Divided by h, and again, provided the limit exists. And then finally, we have the partial derivative with respect to y, and we'll take that partial derivative with respect to y. Analogous notation that we have here. We have the limit as h goes to 0, f sub y of x, y plus h, minus f sub y, xy, divided by h. So we're simply taking partial derivatives of partial derivatives in a similar way that we would do with derivatives.